Okay, welcome back. So let's keep going on AI engineering. It's been a good book so far. So the next section is AI as a judge, and I'll just briefly say what this chapter is about is evaluating the models, because it's one thing to say this model's better than the other. It's another thing to prove it. And in fact, there's methods of proving it that leave a lot to be desired right now. So the next big push that's happening by the smart people is to make these methods more robust. So they've grown quite a lot in the prior few years, but they still need a lot of work. So one of the things I'd like to highlight, based on what I read before, was a chart that shows the different areas of AI research and how they're growing over time. And we can see that AI evaluation, how good is the model doing, lags way behind the rest. So here's that chart right there. So we've got evals, evaluation of performance. Then we've got agent, how well can it act autonomously. Then we've got the interfaces, the prompt engineering, and so on. And we can see mostly, and it makes sense because it's still the early age of AI. The foundation technology itself, the modeling and the training, is where basically all of the attention goes. So what this data is from is the author keeps a list of the 1,000 most popular AI repositories. So this is of that list that the author keeps. What is the nature of each of those
All right, welcome back.
repositories? So we can see most of those
All right,
repositories
welcome back.
have to do with um, the modeling and training of the AIs. But the least amount have to do with the evaluations of the AI. So there's some catching up to do in that regard, and that's why we're kind of in the age of evaluation when it comes to AI research right now. All right, so one of the ways you can evaluate the performance of an AI is to use AI itself as a judge. So that brings me to AI as a judge. The challenges of evaluating open-ended responses led to many teams have led many teams to fall back on human evaluation. As AI has successfully been used to automate many challenging tasks, can AI automate evaluation as well? The approach of using AI to evaluate AI is called AI as a judge or LLM as a judge. An AI model that is used to evaluate other AI models is called an AI judge. While the idea of using AI to automate evaluation has been around for a long time, it only became practical when AI models became capable of doing so, which was around 2020 with the release of GPT-3. As of this writing, AI as a judge has become one of the most, if not the most, common methods for evaluating AI models in production. Most demos of AI evaluation startups I saw in 2023 and 2024 leveraged AI as a judge in one way or another. Langchain's State of AI report in 2023 noted that 58% of evaluations on their platform were done by AI judges. AI as a judge is also an active area of research. Why AI as a judge? AI judges are fast, easy to use, and relatively cheap compared to human evaluators. They can also work without reference data, which means they can be used in production environments where there is no reference data. You can ask AI models to judge an output based on any criteria: correctness, repetitiveness, toxicity, wholesomeness, hallucinations, and more. This is similar to how you can ask a person to give their opinion about anything. You might think, but you can't always trust people's opinions. That's true. And you can't always trust AI's judgments either. However, as each AI model is an aggregation of the masses, it's possible for AI models to make judgments representative of the masses. With the right prompt for the right model, you can get reasonably good judgments on a wide range of topics. Studies have shown that certain AI judges are strongly correlated to human evaluators. In 2023, Zhang et al. Found that on their evaluation benchmark, MT Bench, the agreement between GPT-4 and humans reached 85%, which is even higher than the agreement among humans, 81%. Alpaca Eval authors also found that their AI judges have a near perfect 0.98 correlation with LMSYS's Chat Arena leaderboard, which is evaluated by humans. Not only can AI evaluate a response, but it can also explain its decision, which can be especially useful when you want to audit your evaluation results. Figure 3-7 shows an example of GPT-4 explaining its judgment. Its flexibility makes AI as a judge useful for a wide range of applications, and for some applications, it's the only automatic evaluation option. Even when AI judgments aren't as good as human judgments, they might still be good enough to guide an application's development and provide sufficient confidence to get a project off the ground. So here's figure 3-7. Not only can AI judges score, they can also explain their decisions. So here's a prompt to an AI, and the AI is going to act like a judge. So evaluate the quality of the following paragraph, give it a score from 1 to 5, and explain your decision. Another drawback of this measurement is that higher lexical similarity scores don't always mean better responses. For example, on Human Eval, a code generation benchmark, OpenAI found that blue scores for incorrect and correct solutions were similar. This indicates that optimizing for blue scores isn't the same as optimizing for functional correctness. So the AI would rate the paragraph a 4.5 out of 5, and we'll explain why it does so. So the reason it got such a high mark is because it had three clear strengths. The first one was clarity. The paragraph clearly explains the drawback of lexical similarity scores, providing a specific example. The second one was evidence. It clearly uses the human eval benchmark and OpenAI's findings to support the argument. The third one was conciseness. The paragraph is concise and directly to the point, making it easy to understand. So areas for improvement: flow. The transition between sentences is smooth, but the paragraph could benefit from a slightly stronger connection between the general statement and the specific score. How to use AI as a judge. There are many ways you can use AI to make judgments. For example, you can use AI to evaluate the quality of a response by itself, compare that response to reference data, or compare that response to another response. Here are uh, naive example prompts for these three approaches. So I'm not sure what naive means in this context, but let's look at the prompts. Number one, evaluate the quality of a response by itself given the original question. Given the following question and answer, evaluate how good the answer is for the question. Use the score from 1 to 5. 1 means very bad, 5 means very good. Here's the question and here's the answer. So let's play with this. And we'll use 4 because Pro is just very slow. It's quite annoying how slow it is. Even though 1 is pretty slow because it has the chain of thought, it also has to go through and think, which takes time. So let's try this here. So we're going to say, given the following question and answer, evaluate how good the answer is for the question. Use the score from 1 to 5. Okay, and my keyboard is being annoying, but oftentimes the keystrokes aren't lost, they're just lagging. But in this case, the keystrokes were lost. So I'll have to type out the whole thing again. Following question and answer, evaluate how good the answer is for the question. And this is interesting. I've never seen this before. So we can open this in Canvas. Um, make it shorter, add an emoji, translate to kindergartner. Canvas can do it all. So this is a new feature I've never seen before. Uh, so it's okay. So we could type it in here. Let's try that. Use the score from 1 to 5. 1 means very bad. 5 means very good. Question. Answer. Score. Okay, so let's hit enter and then uh, ask. How do you what's so here's the question. Uh, right, question. How can you improve uh, flavor in cooking? Answer. One method to improve flavor is layering. This means bringing out the particular flavors in a dish by um, stacking them one at a time in layers uh, and using salt to make sure that, for instance, tomatoes taste tomatoey and not just bland. Um, once enough layers are created, and there are particles stuck to the bottom of the pan, you can use something acidic like a cooking wine to free up the stuck on layers, but be careful that they aren't burnt in a thick black layer on the bottom. This freeing up of caramelized uh, layers of flavor greatly enhances the dish. All right, let's see what it has to say about that. So this is Canvas. So okay, I don't know how to use Canvas. So here's my question. So let's feed it that. All right, here's my answer. So, oh, that's just the letter Q. Oh, I get. So Canvas is kind of like a almost like an IDE. So it just gives you a scratch pad to work with, and then when you're done typing out your answer, then you can put it over here and actually give it to ChatGPT. So there we go. So hopefully it will provide the answer here. Yeah, it's basically just like a scratch pad, like a Notepad++ right in the application itself. It looks like. It's interesting that it gave me a 3 out of 5 just for Q. Oh, you know what? It did read what I wrote there. It did read what I wrote there. Oh, okay. Well, I've never used Canvas before. It's kind of, I'm wasting time here, so let's continue. All right, so number two, compare a generated response to a referenced response to evaluate whether the generated response is the same as the reference response. This can be an alternative approach to human des designed similarity measurements. Given the following question, reference answer, and generated answer, evaluate whether this generated answer is the same as the reference answer. Output true or false. So question, reference answer, generated answer. Number three, compare two generated responses and determine which one is better or predict which one users will likely prefer. This is helpful for generating preference data for post-training alignment, discussed in Chapter 2, test time compute, discussed in Chapter 3, and ranking models using comparative evaluation, discussed in the next section. Given the following question and two answers, evaluate which answer is better, output A or B. Question A, first answer, B, second answer. The better answer is a general purpose AI judge can be asked to evaluate a model based on any criteria. If you're building a role playing chatbot, you might want to evaluate if a chatbot's response is consistent with the role users want it to play, such as does this response sound like something Gandalf would say? If you're building an application to generate promotional product photos, you might want to ask from 1 to 5, how would you rate the trustworthiness of the product in this image? Table 3-3 shows common built-in AI as a judge criteria offered by some AI tools. So here's table 3-3 on the next page. These are examples of built-in AI as a judge criteria offered by some AI tools as of September 2024. Note that as these tools evolve, these built-in criteria will change. So we've got Azure AI Studio. Azure is going to become bigger and bigger. Although there is with DeepSeek, there is kind of the question of whether um, there is, like the idea of, oh, is it going to be Azure, is it going to be OpenAI, is, AWS, these are all United States companies, and DeepSeek kind of uh, throws a wrench into the plan, like, oh, well, maybe the big winner is not going to be any United States company at all. Maybe it'll just be this company from out of China. But I think Azure is great. I think it's getting Azure certs makes a lot of sense. So yeah, so these are the examples of built-in AI as a judge criteria. So Azure AI Studio, groundedness, relevance, coherence, fluency, similarity. Those are some things that the AI will judge you on. MLflow.metrics will judge you on faithfulness and relevance. Lane chain criteria evaluation judges conciseness, relevance, correctness, coherence, harmfulness, maliciousness, helpfulness, controversiality, misogyny, um, insensitivity, criminality, which is probably good if you're going to use this for business applications. Regus judges faithfulness and for answer relevance. It's essential to remember that AI as a judge criteria aren't standardized. Azure AI Studio's relevance scores might be very different from MLflow's relevance scores. These scores depend on the judge's underlying model and prompt. How to prompt an AI judge is similar to how to prompt any AI application. In general, a judge's prompt should clearly explain the following. Number one, the task the model is to perform, such as to evaluate the reference between a generated answer and the question. Number two, the criteria the model should follow to evaluate, such as your primary focus should be on determining whether the generated answer contains sufficient information to address the given question according to the ground truth answer. The more detailed the instruction, the better. Number three, the scoring system, which can be one of these classifications, such as good slash bad or relevant slash irrelevant slash neutral, discrete numerical values, such as 1 to 5. Discrete numerical values can be considered a special case of classification, where each class has a numerical interpretation instead of a semantic interpretation. Continuous numerical values, such as between 0 and 1, for example, when you want to evaluate the degree of similarity. Tip: language models are generally better with text than with numbers. It's been reported that AI judges work better with classification than with numerical scoring systems. For numerical scoring systems, discrete scoring seems to work better than continuous scoring. Empirically, the wider the range for discrete scoring, the worse the model seems to get. Typical discrete scoring systems are between 1 and 5. Prompts with examples have been shown to perform better. If you use a scoring system between 1 and 5, include examples of what a response with a score of 1, 2, 3, 4, or 5 looks like, and if possible, why a response receives a certain score. Best practices for prompting are discussed in Chapter 5. Here's part of the prompt used for the criteria relevance by Azure AI Studio. It explains the task, the criteria, the scoring system, an example of how an output with a low score, and a justification for why this input has a low score. Part of the prompt was removed for brevity. Your task is to score the relevance between a generated answer and the question based on the ground truth answer in the range between 1 and 5. And please also provide the scoring reason. Your primary focus should be on determining whether the generated answer contains sufficient information to address the given question according to the ground truth answer. If the generated answer contradicts the ground truth answer, it will receive a low score of 1 to 2. For example, for the question, is the sky blue? The ground truth answer is yes, the sky is blue. The generated answer is no, the sky is not blue. In this example, the generated answer contradicts the ground truth answer by stating that the sky is not blue, when in fact it is blue. This inconsistency would result in a low score of 1 through 2, and the reason for the low score would reflect the contradiction between the generated answer and the ground truth answer. So figure 3-4 shows an example of a AI judge that evaluates the quality of an answer when given in the question. You can see how quickly this can go awry, because yes, the sky is blue. Today it's kind of whitish gray. If you're on another planet, if you're on the moon, the sky is going to be black. So in the mornings and evenings, the sky might be more orange. So it is true that the sky is blue, but a fundamental ground truth answer, like not necessarily. Like the California wildflowers, the sky was likely not blue. On another planet, the sky is probably not blue. So, okay, so this is figure 3-8, an example of an AI judge that evaluates the quality of an answer given a question. So this is the difference between, like, an AI model and a human. A human could go to another planet and say, oh, the sky's not blue on this planet, it's black. But an AI can't do that because it would contradict the ground truth answer, and the ground truth answer, if it's not sophisticated enough to allow the AI to make a proper observation, then it won't make a proper observation. All right, so object to be evaluated, question, comma, answer. Template So prompt template for criteria. Given the following question and answer, evaluate how good the answer is for the question. Use the score from 1 to 5. Final prompt, model GPT-4, and then it gives you a score. An AI judge is not just a model, it is a system that includes both a model and a prompt. Altering the model, the prompt, or the model's sampling parameters results in a different judge. So with that, I need to take a break. I'll be right back. All right, I'm back. So next section is limitations of AI as a judge. Despite the many advantages of AI as a judge, many teams are hesitant to adopt this approach. Using AI to evaluate AI seems tautological. The probabilistic nature of AI makes it seem too unreliable to act as an evaluator. AI judges can potentially introduce non-trivial costs and latency to an application. Given these limitations, some teams see AI as a judge as a fallback option when they don't have any other way of evaluating their systems, especially in production. Inconsistency. For an evaluation method to be trustworthy, its results should be consistent. Yet AI judges, like all AI applications, are probabilistic. The same judge on the same input can output different scores if prompted differently. Even the same judge, prompted with the same instruction, can output different scores if run twice. This inconsistency makes it hard to reproduce or trust evaluation results. It's possible to get an AI judge to be more consistent. Chapter 2 discusses how to do so with sampling variables. Zhang et al. In 2023 showed that including evaluation examples in the prompt can increase the consistency of GPT-4 from 65% to 77.5%. However, they acknowledged that high consistency may not imply high accuracy. The judge might consistently make the same mistakes. On top of that, including more examples makes prompts longer, and longer prompts mean higher inference costs. In Zhang et al.'s experiment, including more examples in their prompts uh, caused their GPT-4 spending to quadruple. Criteria ambiguity. Unlike many human-designed metrics, AI as a judge metrics aren't standardized, making it easy to misinterpret and misuse them. As of this writing, the open source tools MLflow, Ragus, and Llama Index all have the built-in criterion faithfulness to measure how faithful a generated output is to the given context. But their instructions and scoring systems are all different. As shown in Table 3-4, MLflow uses a scoring system from 1 to 5. Ragex uses, or Ragas uses 0 and 1, whereas Llama Index's prompt asks the judge to output yes or no. So this is table 3-4. These are different tools, can have very difficult default prompts for the same criterion. So we've got the tool, the prompt, partially omitted for brevity, and the scoring system. So the first tool is MLflow. Here's the prompt. Faithfulness is only evaluated with the provided output and provided context. Please ignore the provided input entirely when scoring faithfulness. Faithfulness assesses how much of the provided output is factually consistent with the provided context. And it's abbreviated for brevity to include for this book. You can imagine that the full prompt is quite a bit longer and more sophisticated than that. So faithfulness. Below are the details for different scores. Score 1. None of the claims in the output can be inferred from the provided context. Score 2, and then it's abbreviated. So then the scoring system is 1 through 5, and that's MLflow. So Ragas, Ragas, Ragas. The prompt is your task is to judge the faithfulness of a series of statements based on a given context. For each statement, you must verdicts. Return uh, for each statement, you must return verdict AS1 if the statement can be verified based on the content, or 0 if the statement can not be verified based on the context. I don't see any ellipsis there, but I'm guessing this is abbreviated too. The scoring system here is 0 and 1. I'd be surprised if. Oh, I see. So this is what happened. Your task is to judge the faithfulness of a series of statements based on a given context. For each statement, you must return uh, verdict as. So normally when you write on a new line and you split up a word, you would use like a dash. But here they didn't do that, so I was confused what that meant. But you return return verdict as 1 if the statement can be verified based on the context, or 0 if the statement cannot be verified based on the context. So there we go, returning 1 or 0. The next one is llama index. Please tell if a given piece of information is supported by the context. You need to answer with either yes or no. So the criteria is yes or no. Answer yes if any of the context supports the information, even if most of the context is unrelated. Some examples are provided below. Information. Apple pie is generally double crusted. Context. An apple pie is a fruit pie. It is generally double crusted with pastry both above and below the filling. Answer yes. Yeah, you know what? I guess that's true. Yeah, definitely. Yeah, that would be kind of a unique and rare apple pie if it wasn't double crusted. We can see just about all of the images. So far as I can see, every image except for this one here is double crusted, and this is an apple custard pie. It's not just a plain traditional apple pie. So yeah, they're double crusted for sure. The faithfulness scores outputted by these three tools won't be comparable. If given a context answer pair, MLflow gives a faithfulness score of 3, uh, Regis outputs 1, and Llama Index outputs no. Which score would you use? An application evolves over time, but the way it's evaluated ideally should be fixed. This way, evaluation metrics can be used to monitor the application's changes. However, AI judges are also AI applications, which means that they can change over time. Imagine that last month your application's coherence score was 90%, and this month this score is 92%. Does this mean that your application's coherence has improved? It's hard to answer this question unless you know for sure that the AI judges used in both cases are exactly the same. What if the judge's prompt this month is different from the one last month? Maybe you switched to a slightly better performing prompt, or a coworker fixed a typo in last month's prompt. The judge this month is more lenient. This can become especially confusing if the application and the AI judge are managed by different teams. The AI judge team might change the judges without informing the application team. As a result, the application team might mistakenly attribute the changes in the evaluation results to changes in the application, rather than the changes in the judges. Tip: do not trust any AI judge if you can't see the model and the prompt used for the judge. Evaluation models take time to standardize as the field evolves and more guardrails are introduced. I hope that future AI judges will become a lot more standardized and reliable. That's true. And we can see one of the big things to note between the differences of this response is they don't even have the same granularity. There's one that can say that. So there's two here. The two of the three listed here, two of them are yes or no, a binary on or off. But there's one that it could be anywhere from a one to a five. So not only is there a binary off, being that it's either a two or a four, or a one or a five, definitively on one side or the other. There's strengths of binary on or off. It could be a one or a two, or it could be a four or a five. And not only that, there's a neutral answer, three, where it's neither binary on or off, whether or not it passes or fails. So that one through five is quite different in the answers it can give than these zero and one or yes or no's. So it's not only is there no standardization, there's no standardization even with like the granularity of the assessment. Increased costs and latency. You can use AI judges to evaluate applications both during experimentation and in production. Many teams use AI judges as guardrails in production to reduce risks, showing users only generated responses deemed good by the AI judge. Using powerful models to evaluate responses can be expensive. If you use GPT-4 to both generate and evaluate responses, you'll do twice as many GPT-4 calls, approximately doubling your API costs. If you have three evaluation prompts because you want to evaluate these criteria, say overall response quality, factual consistency, and toxicity, you'll increase your number of API calls four times. You can reduce costs by using weaker models as the judges. See what models can act as judges. You can also reduce costs with spot checking, evaluating only a subset of responses. Spot checking means you might fail to catch some failures. The larger the percentage of samples you evaluate, the more confidence you will have in your evaluation results, but also the higher the costs. Finding the right balance between cost and confidence might take trial and error. This process is discussed further in Chapter 4. All things considered, AI judges are much cheaper than human evaluators. Implementing AI judges in your production pipeline can add latency. If you evaluate responses before returning them to users, you face a trade-off: reduced risk but increased latency. The added latency might make this option a non-starter for applications with strict latency requirements. Biases of AI as a judge. Human evaluators have biases, and so do AI judges. Different AI judges have different biases. This section will discuss some of the common ones. Being aware of your AI judges' biases helps you interpret their scores correctly and even mitigate these biases. AI judges tend to have self-bias, where a model favors its own responses over the responses generated by other models. The same mechanism that helps a model compute the most likely response to generate will also give this response a high score. In Zhang et al.'s 2023 experiment, GPT-4 favors itself with a 10% higher win rate, while Claude V1 favors itself with a 25% higher win rate. Many AI models have first position bias. An AI judge may favor the first answer in a pairwise comparison or the first in a list of options. This can be mitigated by repeating the same test multiple times with different orderings or with carefully crafted prompts. The position bias of AI is the opposite of that of humans. Humans tend to favor the answer they see last, which is called recency bias. Some AI judges have verbosity bias, favoring lengthier answers regardless of their quality. Wu and Agi in 2023 found that both GPT-4 and Claude-1 prefer longer responses, around 100 words, with factual errors over shorter correct responses, 50 words. So even if there were errors in it, the fact that it was longer meant that it preferred it. And you know, what is the color of the sky? It's blue. You know, what is the color of the sky? Well, the color of the sky could be bright pink, orange. If a rabbi shakes his fist hard enough, you know, that's a longer answer. It's obviously wrong. The color of the sky does not change no matter how hard a rabbi shakes his fist. But the AI as a judge would possibly say that is the more accurate answer simply because the answer is longer. Sato et al. In 2023 studied this bias for creative tasks and found that when the length difference is large enough, for example, one response is twice as long as the other, the judge almost always prefers the longer one. Both Zhang et al. In 2023 and Seato et al. In 2023, however, discovered that GPT-4 is less prone to this bias than GPT-3.5, suggesting that this bias might go away as models become stronger. On top of all these biases, AI judges have the same limitations as all AI applications, including privacy and IP. If you use a proprietary model as your judge, you'll need to send your data to this model. If the model provider doesn't disclose their training data, you won't know for sure if the judge is commercially safe to use. Despite the limitations of the AI as a judge approach, its many advantages make me believe that its adoption will continue to grow. However, AI judges should be supplemented with exact evaluation methods and or human evaluation. So I need to take a break, close to a major ending, but I'll take a break. All right, I'm back. So let's keep going. Looks like I'm keep hitting the red, which is bad. I apologize for that. So let's see if this is better. All right. So next section will be what models can act as judges. The judge can either be stronger, weaker, or the same as the model being judged. Each scenario has its pros and cons. At first glance, a stronger judge makes sense. Shouldn't the exam grader be more knowledgeable than the exam taker? Not only can stronger models make better judgments, but they can also improve weaker models by guiding them to generate better responses. You might wonder, if you already have access to the stronger model, why bother using a weaker model to generate responses? The answer is cost and latency. You might not have the budget to use the stronger model to generate all responses. So you use it to evaluate a subset of responses. For example, you may use a cheap in-house model to generate responses and GPT-4 to evaluate 1% of the responses. The stronger model also might be too slow for your application. You can use a fast model to generate responses while the stronger but slower model does evaluation in the background. If the strong model thinks that the weak model's response is bad, remedy actions might be taken, such as updating the response with that of the strong model. Note that the opposite pattern is also common. You can use a strong model to generate responses with a weak model running in the background to do evaluation. Using the stronger model as a judge leaves us with two challenges. First, the strongest model will be left with no eligible judge. Second, we need an alternative evaluation method to determine which model is the strongest. Using a model to judge itself, self-evaluation, or self-critique sounds like cheating, especially because of self-bias. However, self-evaluation can be great for sanity checks. If a model thinks its own response is incorrect, the model might not be that reliable. Beyond In beyond sanity checks, asking a model to evaluate itself can nudge a model to revise and improve its responses. This example shows what self-evaluation might look like. So prompt from a user, what is 10 plus 3? First response from the AI would be 30, which is incorrect. Self-critique from the AI, is this answer correct? And now here's the answer from the judge. A final response from the AI, no, it's not. The correct answer is 13. So it can do a sanity check on itself and give you the correct answer of 13. From one open question is whether the judge can be weaker than the model being judged. Some argue that judging is an easier task than generating. Anyone can have an opinion about whether a song is good, but not everyone can write a song. Weaker models should be able to judge the outputs of stronger models. Zhang et al. In 2023 found that stronger models are better correlated to human preference, which makes people opt for the strongest models they can afford. However, this experiment was limited to general purpose judges. One research direction that I'm excited about is small specialized judges. Specialized judges are trained to make specific judgments using specific criteria and following specific scoring systems. A small specialized judge can be more reliable than larger general purpose judges for specific judgments. Because there are many possible ways to use AI judges, there are many possible specialized AI judges. Here I'll go over examples of three specialized judges: reward models, reference-based judges, and preference models. Reward model. A reward model takes in a prompt, comma, response pair and scores how good the response is given the prompt. Reward models have been successfully used in reinforcement learning from human feedback for many years. CAPI is an example of a reward model developed by Google in 2023. Given a pair of prompt, comma, response, CAPI produces a score between 0 and 1, indicating how correct the response is. CAPI is a lightweight score with 360 million parameters, much smaller than general purpose foundation models. Reference-based judge. A reference-based judge evaluates the generated response with respect to one or more reference responses. This judge can output a similarity score or a quality score, how good the generated response is compared to the reference responses. For example, uh, BlueRT takes in a candidate response, reference response pair, and outputs a similarity score between the candidate and reference response. Prometheus takes in prompt generated response, reference response scoring rubric, and outputs a quality score between 1 and 5, assuming that the reference response gets a 5. Preference model. A preference model takes in prompt response 1, response 2, as input and outputs, which of the two responses is better, preferred by users for the given prompt. This is perhaps one of the more exciting directions for specialized judges. Being able to predict human preference opens up many possibilities. As discussed in Chapter 2, preference data is essential for aligning AI models to human preference, and it's challenging and expensive to obtain. Having a good human preference predictor can generally make evaluation easier and models safer to use. There have been many initiatives in building preference models, including Panda LM and Judge LM. Figure 3-9 shows an example of how Panda LM works. It not only outputs which response is better, but it also explains its rationale. All right, so this is figure 3-9, an example output of Panda LM given a human prompt and two generated responses. Picture is from Wang et al. In 2023. It's modified slightly for readability. The original image is available under the Apache license 2.0. So we've got a number of so this is an example of an output from Panda LM. So the input comes from the human. The instruction is explain the meaning of the given phrase in simple terms. Use an example if possible. It would be helpful if you could give an example. So the input is with a little give in them, and then response one from Bloom. These are responses to be evaluated. It is with a little bit of flexibility, they can bend and adapt to different situations. And then the other one is with a little give in them means to have a bit of flexibility or room for a compromise. So the first response kind of fills in the rest of the sentences. So with a little given them, so it kind of explains the phrase by flushing it out more. So with a little bit of flexibility, they can bend and adapt to different situations. And the second one kind of just gives a definition to the phrase. So the phrase with a little given them means that they have a bit of flexibility or room for compromise. So which one's better? If a person were using your AI, which one would they rather see? So Panda LM says response two is better because it gives a clear and concise explanation of the meaning of the phrase. Reference response. The phrase with a little given them means to have a bit of flexibility or room for a compromise. So it considers two to be a better response. Despite its limitations, the AI as a judge approach is versatile and powerful. Using cheaper models as judges makes it even more useful. Many of my colleagues who were initially skeptical have started to rely on it more in production. AI as a judge is exciting, and the next approach we'll discuss is just as intriguing. It's inspired by game design, a fascinating field. Yeah, game design is a really sophisticated field too. It's a Oh, this chapter is almost done. All right, let's move the that's up there. Okay. Delete that, yep. So I think that's going to be it for this video. I'm near the hour mark. I don't think I can finish the chapter in this video. So this is just a really like natural stopping point. Yeah, so this is just a really natural place to stop. So I'm going to do that. Um, so when we come back, it'll be ranking models with comparative evaluation. So thanks for watching and see you in the next one.